So you've received your Raspberry Pi and your breadboard and all these other fun toys in the mail, but you have no instructions on what to do. You're not really sure how to get started and obviously don't want to fry your brand new Raspberry Pi. So I'm creating this video to share with you what I've learned in my work with the Raspberry Pi, and at the end of this video we'll have a functioning breadboard with LEDs that we can turn on and off via the Raspberry Pi. So what we're looking at here, the parts, we have a Raspberry Pi 3 Model B that I've assembled to the Raspberry Pi official touchscreen, which is really awesome. Even though you'll likely connect to the Raspberry Pi via either SSH or VNC, sometimes it is handy to have that touchscreen attached, and it's pretty reasonably priced as well. This video will not cover mounting the monitor, but I will zoom in here so you can at least see how it connects. So mine actually came assembled with the touchscreen's board connected to the touchscreen. So all I had to do was mount the Raspberry Pi on top and connect this ribbon cable over here. So this shot might be helpful to you to see how the ribbon cable attaches. You might find, like I did, especially after you connect the breadboard, that the display actually sits better upside down. So you're actually able to turn the Raspberry Pi upside down, and there's a software configuration command that I'll include in the blog post that tells you how to flip the screen so that if it's easier for the Raspberry Pi to sit upside down. So over here we have a red, yellow, and green LED that will plug into the breadboard, and we have some resistors. So the deal with LED lights is they'll take as much power as they can get, which can cause them to burn very brightly and therefore burn out quickly. So what the resistors allow you to do is reduce the amount of power going to the LEDs so that they'll be a bit dimmer and not burn out so quickly. The breadboard, what the breadboard allows us to do, so instead of actually soldering these LEDs onto the Raspberry Pi itself, instead we can connect the breadboard to the Raspberry Pi, stick the LEDs inside the LED board or inside the breadboard, and not have to get the soldering iron out. The way we do that also is with this ribbon cable that we connect between the Raspberry Pi and the breadboard via what's called this T-shaped cobbler, and I'll also show you how to install that on the breadboard because I did not similarly have any instructions on how to do that, and I wasn't real confident on how that goes on. So I'll show you how to install the T-shaped cobbler onto the breadboard and connect it to the Raspberry Pi via the ribbon cable. Then we'll install these LEDs, the resistors, and the jumper wires that actually send power to the LED lights. And then also we have a reference card that we'll refer to that helps us know which actual pens that we should use for the LEDs. So the first thing we're going to do is install the T-cobbler onto this breadboard. And if you haven't done this before, you might be wondering, gosh, which way does this go? Where do I put the pins in? Not really sure what to do. The good news is there are really only a couple of things that matter. You could really stick these in anywhere. The most important thing is to align to make sure you have the 5 volts on the correct side and to make sure the positive and negative are going the correct way. So you can see that on the T-cobbler we have positive on the left, negative on the right, on both sides. So you want positive on the left, negative on the right. If you connected it like this, now you've got it backwards. So it's important to have the breadboard, again, with the positive on the left, the negative on the right. And the way this breadboard works, which wasn't clear to me at first, is within these rows, A through E, and then F through J, A through E are all sharing the same current. So it doesn't really matter if you're in row 27, for example, it doesn't really matter whether you use A, B, C, D, or E. They're all in the same row. It does matter that when you do an additional light, for example, that it be in a different row. It also matters that the positive and negative be in a different row, and we'll cover that when we get to those steps. Similarly, just as these rows share current going horizontally, the positive and negative shares current vertically. So similarly, it doesn't really matter which row you plug in for positive or for negative, because this is all sharing current. So when you plug in the T cobbler, you need to make sure that the plus and the positive and negative on each side are aligned with positive and negative on each side here, and that will actually send the current down vertically throughout the entire column for positive and negative. So what you want to do is, I just picked the highest it could go. So you'll notice on this, the positive and negative are actually a couple of rows lower than in the middle here. So what you want to do is have these top pins in the middle here align with row 1, and you don't really care where the positive and negative line up as long as you have the plus and minus correct. So you just kind of look on the side here, find where the row 1 is for the middle. You'll see the positive and negative, they end up kind of going down on the second row there, making sure it's straight, and then just gently and firmly pressing that into place. And again, just double checking that your positive and negative here match up with the orientation on the breadboard. And looking on the back, similar setup. So what this does now is basically you now have the voltage here going down vertically. This whole thing will have voltage, and similarly this whole thing down here. And then for these pins here, which correspond to the pins on your Raspberry Pi, each pin here is then sending current across the entire row for that number. So I think it's important first to just kind of understand how this works and what you're doing, so that when you plug the lights in, you understand, you know, why you put which pin where. So the next thing we're going to do, now that we have the T cobbler in here, is we're going to connect this to the Raspberry Pi. There's one potential gotcha here where you have to be careful. You need to make sure that pin 1 on the breadboard aligns with pin 1 on the Raspberry Pi. Now fortunately, this T cobbler has a key here that won't let me do it the wrong way. So that's nice. If yours does not have that, what you want to know is that pin 1 is going to be on the right side. So on your ribbon cable, the ribbon cable, you'll notice, has this one on the right side here with the red stripe. The red stripe indicates that this is pin 1 on the ribbon cable. And pin 1 is going to be over here. And I have the key here, so I know that this can only go in one way. So I line this up and I push it in firmly. So now I have pin 1 on the breadboard and all these 40 pins here throughout here going through this cable. The next step is to attach this to the Raspberry Pi. The Raspberry Pi does not have the key, so this is where you have to be careful to not put the ribbon cable on backwards. So on the Raspberry Pi, we know that pin 1 is over here on the left side, and be careful with your orientation. So with the GPIO on the top and the ports over here on the right, and to clarify, this is a Raspberry Pi 3 Model B. If you have a different model, just double check your orientation to make sure you know where pin 1 is on your Raspberry Pi. So whichever side pin 1 is on, that's the side that's going to receive the red cable here. So we're going to take this and very carefully and gently line this up. Once we're sure it's on all of them, gently press down, doing a little bit better job than I did of pushing it down straight at the same time. By the way, I should have pointed this out earlier. You want to be doing all this while there's no power going to your Raspberry Pi. So just completely unplug your power. The other thing that you may run into if you have the touchscreen like I do, When you install the touchscreen, there are actually 3 different ways to power the Raspberry Pi from the touchscreen, because you typically send the power to the touchscreen and then the touchscreen provides power to the Raspberry Pi. The default way of doing that is actually with a couple of jumpers from the GPIO board down to some pins on the display board. So obviously we can't do that now because we have this breadboard connector in place. So the other 2 ways to power the Raspberry Pi would be you could just have it independently powered via the USB, just like you're likely doing now if you don't have the touchpad, but then you're stuck with 2 power supplies, one for the monitor and one for the display board. So what's a simpler solution, and what I moved to after getting the breadboard, is you continue to power your display board with the USB, and then you can get a small USB cable that goes from the USB on the display board to the power input on the Raspberry Pi, and that way you still just have one AC adapter. So here's the cable I have here. I have on my shopping list to get one that's a bit shorter because you don't really need one this long. But basically you'll have your power source going into the display board here. The display board actually has a single USB port on it that we can use for power. Obviously you need to put the USB in the correct orientation, and then you power the Raspberry Pi from the display board. And then the last thing we'll do is plug the power into the display board to power up everything. So now we have the breadboard in place, and you'll see this is what I was talking about, where the default orientation for the touchscreen is for it to go this way, which doesn't work really great with all these wires down here, and we don't even have any other wires plugged in. So you might want to actually reverse the orientation, and then what happens is your ribbon cable ends up working as a stand. That's probably not the smartest stand to use, but it's light enough that it's not really putting pressure on that ribbon cable. But that's the better approach would be to have a true stand. But as long as you don't have much weight here and it's gentle, this can actually serve as a stand as well. So at this point, we're now ready to start installing pieces on the breadboard. When you take a particular LED, you'll notice that one leg is slightly longer than the other. The longer leg is the positive side, and the shorter leg is the negative side. And it's really important to keep track of which end, whether you're doing positive or negative, goes into which row. So in our case, and again, it doesn't really matter which row we pick, we just want to keep track of which is positive and which is negative. I'm going to do the positive end closer to the camera, and so this is just whatever row you want, in whatever column you want. We're going to stick the positive in one of the holes and the negative above it. It's important that the positive and negative not be in the same row, so you do need to do this vertically and not horizontally. Then we'll take the yellow one, we'll do the same thing, we'll be consistent to keep track of which is positive and which is negative. And I'm just going to double check, yep, we did the positive towards the camera, so we're going to do the longer leg, the positive, towards the bottom. We'll just go the next 2 rows there, and we'll do the same thing with green, putting the positive in closer to the camera. The next thing we need to do is install the resistors so that we can limit the amount of power that goes to these. The resistors, you basically jump between the negative leg of the LED and the negative on the power side. So again, it doesn't really matter which column that we go in, but we need to go in the same row as the negative. So I'm going to pick the one just right next to it in the negative there, and then put the other leg in the negative on the power side, being careful that I get the negative and not the positive. We're going to repeat that for the next two colors. We're going to grab the negative on the yellow and stick it over here in the negative. Yep, you got to be careful not to go into the positive. This is why we do this with no power current applied. And the same thing on the green. We're going to put one in the negative and again over in the negative. And for the negative row, it doesn't matter if it's exactly in the right row, it just needs to be in any one of these. And I'm just going to double check that this all looks correct. Yep. So the last thing we need to do is we need to do the jump wires to connect the row that the positive is plugged into from the light and jump that to the corresponding GPIO pin on the Raspberry Pi. I've got a nice little cheat sheet here. It's also written on the board, but this is a little bit easier on the eyes, where you can see the pin, what the corresponding GPIO number is, which will be important later when we're turning it on or off from software, and then which ones are available. So we can see that GPIO 17, 27, and 22, these three green ones right here, which corresponds to 11, 13, and 15, we can see that those are all available, so we can grab those for the three lights. So what we're going to do, pretty straightforward again, is we're going to stick one pin in the same row that the positive is in. And again, it can be any column, it doesn't matter. And we'll do the first one to GPIO number 22. And again, it can be any column, just needs to be in the right row. Then we're going to do the yellow's positive. That looks like I grabbed the negative by accident. Okay, we've got the yellow's positive going into 27. And I'm going to take the green's positive. And you'll notice, since I put the lights right next to each other, this kind of ends up being every other pin for the positive, every other pin for the resistor, because the way the lights go, it goes positive, negative, positive, negative. And this one we're going to put into 22. Let me just double check this. And my eyes were definitely off, so I need to move these over one. So 17, 27, and 22. It doesn't, at this point, it doesn't matter which color goes into which number. We just need to know which color is on which number when we get to the software portion. So I connected the three lights to GPI ports 17, 27, and 22. That corresponds to pins 11, 13, and 15. And I'll include a close-up picture on this. We've got the three resistors into the negatives. And at this point, we should be good to go. So at this point, we're ready to turn it on and issue some commands to light up the lights. So as I mentioned earlier, my Raspberry Pi is actually getting power from the Raspberry Pi touchscreen. And now when I plug in the power to the touchscreen, the entire system will boot up. I have a small Bluetooth keyboard that I will use to keep the entire demo running from the Raspberry Pi. As you can see, the Raspberry Pi is now booted up using the Raspberry Pi touchscreen. We'll open a terminal window. Need to connect the Bluetooth keyboard. So the first thing I have to do with the WiringPi commands, which I'll outline in the blog, is I have to put these specific pins in output mode rather than input mode, because we're sending a signal to these devices, the LED lights, rather than receiving a signal back from them. And then we will turn them on, and these details will be, these statements, these commands will be outlined in the blog here. So we're going to say we used pins 17, 27, and 22. So I'm putting each of those pins in output mode. We've turned on the green light. Turned on the yellow light. And we turned on the red light. So that is just fantastic. All three lights worked. You could obviously have these lights turn on or off in response to events. You can blink them. You can do as much as your imagination will allow via programming. In this case, I'm just simply turning them on and off. If we want to turn the yellow one off, I just say, okay, for that pin number 27, let's kill the power there. Nope, let's turn it back on. Same thing, I can do it for the green pin. However I want to control these lights, I can turn them on and off.